Okay, this is Karen Launchbaugh here with a few tips on how to report data for REM 410. I want to give you a few tips on tables, figures, and then how to use those figures to make your points. Okay, first let's start with a few tips about tables. You can use either tables or figures in your final answers to the questions, but let's start with a few tips from tables. I want to just remind you not to use raw data in your reports. When you go to write the answers on those answer sheets, use only final tables or figures. You, of course, use Excel or spreadsheet or other spreadsheet program to summarize your data, but then submit only a clearly formatted table or figure in your answer sheet for the assignment. So cut and paste and put those clearly formatted tables or figures in your answer sheet. The reason that we're doing this is because the goal of the class is to gain skill in reporting data as well as collecting and summarizing data. So here's an example of a chart that is truly difficult to follow. This is a figure, a lot of errors in it. Take a look at that. It's really hard to compare or see what's going. Here's some problems I see with it. First of all, I see numbers repeated, 2.2, 1.3. They're both repeated twice. When you have the same number, don't repeat them. Also, we don't know what units are. Units what? Units squared, miles squared, centimeters squared, so the units are not clearly stated. Also, the label, the heading, the variable, BYG, is truly unclear. What the heck is BYG? It's a variable acronym, but it's not clear what that variable is. And then finally, here's what that table would look like if it was cleaned up. It turns out BWG stood for Blue Bunch Wheatgrass. Who'd have thunk it? Western yarrow was the other plant. Density was plants per plot. In the heading, it tells what how big a plot was, 0.9 feet squared. It has the standard deviation and the confidence interval of 95%. So this was a table that was actually submitted by a student in a past year, and the table title is clear. It's pretty clear what was on Transect 1 and 2, and hopefully in their discussion we would learn if there were any differences between Transect 1 and 2 and why. You might remember these data. We talked about bitter brush in one of the assignments, and here was the raw data. This is where you might start with your table, but one of the points I want to make here is thinking about significant digits. Look at the mean and standard error at the bottom of this chart. You need to clean those up so that you're using the same number of units beyond the decimal and that the number of those units is appropriate. So we went from multiple and irregular numbers of units beyond the decimal to just one unit beyond the decimal. It's kind of hard to decide, but my sort of rule of thumb is that the unit should be just one unit greater than you could estimate. So in the field, we estimated percent cover to the nearest percent. So that means that we could have 1 unit beyond the decimal to 1/10 of a percent. So you can usually go just a smidgen more than you would be able to do it in the field, than you would be able to measure in the field. I'm going to give you an example of the assignment, or of the data that we completed for the last assignment. Remember that perennial and annual grass cover data for the OX ranch. Here's a few steps that you might have used to create a final table. These are kind of the general steps that I use when I create tables. Nothing magical about them, but this is kind of the process that I go through. First of all, I enter the data in a spreadsheet. You all saw these data. I provided them for you in assignment 1. And remember, don't report raw data. So I'm going to take these raw data and I'm going to create a table with them. So I've gotten rid of the raw data. Now I just have the summary statistics at the bottom. I've got average, mean, standard deviation, standard error, and confidence interval. One key point is to use only one estimate of variation. So use only the standard deviation, the standard error, or the confidence interval. So when you're trying to figure out what data to present, in this case it's pretty clear we're going to want the mean, or the average, and we're going to want one estimate of variation. In this case I decided to use the mean and the confidence interval. So my table is shaping up, gotten rid of the raw data, we've selected which variables to use in our final table. So the next step would be to clean up the data. This is where that significant digits comes in. So again, in the first table I had 4 or 5 units beyond the decimal point. That's really unrealistic since we measured plants as a percent. I think we were able to calculate at least 1/10 of a percent, or 1 unit beyond the decimal, for percentage ground cover. And so we're going to use that same 1/10 or 1 unit beyond the decimal for both mean and confidence interval. So now the data is looking cleaner. It's a lot easier to see differences when you get rid of all those extraneous units beyond the decimal. It's also pretty easy to see if there's overlapping confidence intervals. You got to do a little math in your head, but it's pretty clear that the intervals do overlap for the different years that we had in this table. If you're not clear at how to get rid of those extraneous variables, just take a look at the top. When you're in Excel, look at that top banner, and on the home banner there's a column called numbers, and I've circled here a little figure. I never knew what that was for years, but what that does is allows you to get all of the variables that you highlight in a table to have the same number of units beyond the decimal. So what you do is you highlight the variables in your table that you want all to have the same number of units beyond the decimal, and then click on these either left or right to create even more or less units beyond the decimal. So try that. It's one easy way to do it. This other way to do it would be to highlight the areas that you want all the units to be correct on, and use a right click and format. And under the format you can create percentages or numbers with a specific number of units beyond the decimal. Next step is to set up your table in a way that it's easy to make the comparisons that you want to make. In this case, it's pretty simple. About the only two things you could compare was you could compare annual to perennial grasses, and you could compare cover from 2002 and 3 to 2012. And in either case, this table would be pretty easy to make those comparisons. So there's more complicated tables, but this one works pretty well. You can compare annuals and perennial grasses, and within each of those you can look at the comparison from 2002 and 3 to 2012. The final step is to check all your units and headings. Make sure your units are clear. For example, is it percent cover, plants per meter squared, plant height in centimeters, etc. Those would be units. Each variable must be written out clearly and fully. So in this case we have annual grass and perennial grass. We have average percent cover, 90% confidence interval. All of those seem pretty clear to me. Remember in my previous example I had that BWG. It was really unclear what that was, so don't abbreviate. Go ahead and write them out, or if you do abbreviate, make sure it's clear. And again, if you're writing the same thing several times, something's wrong with the way that you printed it out, probably, that you created the table. One more thing. You need to add a title, because remember that your table should stand alone. I had a professor that told me once that you should be able to make a table, and if it drops on the ground on your way to the car and someone comes by and finds it in the parking lot, they should know what the data in the table is representing. So here's a pretty good example of what our table might look like if we created a figure 1 title, and it might say a comparison of ground cover of annual and perennial grasses sampled at the OX Ranch in central Idaho. Examinations were done in 2002 and 3, and all plots were re-examined in 2012. So it's pretty clear that we did ground cover. It's now clear why we have a 2002 and /03. We know where the data were collected and roughly when they were collected. So a table should include where, when, and what is being reported. You can see that over a series of steps we went from almost raw data, just raw summarized data, into a really clear, clean graph that is easy to make comparisons from. So let's go on to graphs. I'm just going to give you some overviews about how you might use graphs in your report. There's really only 3 kinds of graphs in the world. One is to compare data, the second is to show composition of data, and the third is to look at distribution of data. So you're using graphs to kind of make your point and to show what the data are saying. Here's a really nice graph from a paper that was presented in the past in this class. It has all the right elements. On the left-hand side, it says plants per plot. It shows me I've got transect 1 or 2. It has a measure of variation. It uses a nice bar chart. And then the title makes it all clear. Mean plant density along 2 transects examined at the Wayland Cemetery Remnant Prairie on September 11, 2015. Blue bunch wheatgrass and western yarrow were examined in the plots. that were 0.96 feet squared, and the error bars represent a 95% confidence interval. Wow, so that's really clear. It's got all the right elements. I just want to talk a little bit about whether horizontal or vertical charts are important or appropriate. In this case, we were doing a study on red, yellow, and green dots. We were looking at density, and here they have the number per inch squared. So they've got the units in the table and on the axis. It's a little weird. In this case, you could use a horizontal chart as well as a vertical bar chart. Doesn't often matter. Sometimes one chart works better than others. You could not use a line chart for these kind of data because green, blue, and white species are not a continuous variable. So in this case, you can't have green and a half. And a line chart kind of indicates that there could be something between each point along that line. In this case, it's not appropriate. In this case, it would be. For example, we know that on the y-axis, the temperature in Fahrenheit is continuous variable. You can have 50 and 70, and that in between that would be 60 degrees. So that's a continuous variable. So we can use a line chart. Scatter plots are when you're trying to look at a relationship between units, and here's an example of a scatter plot where we just used the temperature on the x-axis and rainfall on the y-axis, and we can see there's a relationship between temperature and rainfall in this example. Composition of data is when you want to take the whole samples and you want to try to say which were the most dominant aspects of that sample. And this was a chart that I just got off the internet from Steve Nelson. He was looking at Rolette County, North Dakota, and he was looking for the different kinds of soils there. And it looks like the dominant soil is a mixed hardwood prairie soil. And he shows where he got the data and when he collected it. So it's pretty clear. Sequential graphs are unusual. I don't think we'll use them in this class, but it's when you want to look at what is happening across the plot. So if we want to see how much, for example, how much of one species there might be at the bottom of a transect, and then at the end of the transect, that might be useful if we were going up a hill or getting into a drier soil. But usually sequential graphs are not useful, but they are used when you want to look at how something occurred over time or space on the x-axis. I've given you a few examples of charts in this presentation so far, but here's a few bad examples of charts that I've gotten in this class in the past. Here's one. There's really no way to compare these different species, yellow, green, and blue, because all this person did was looked at in each plot how much of each species, the number of individuals of each species there was. So it's a really poor comparison. Here's one that's even worse. There's no y-axis title, there's no x-axis title. I don't know what series 1, 2, or 3 are. So this person made the first step to make a graph, but it's really not effective as a comparison. Here's another one that I would say is not effective. Again, looking at the plots along the x-axis, totally not relevant in this case. And density per plot, just hard to say what is going on here. So in summary, there's just a few tips to leave you with when you're creating figures. 1, make sure that the figure is complete. Make sure it has axis titles, legend titles, and that the whole figure itself has a very complete title, knowing when, where, what was presented. Make sure the units of the variables are included, and make sure those variable names are complete. Don't use a lot of acronyms so that someone could identify what's going on in the chart. Use a line chart only if the variable is a continuous variable. So we talked about in this presentation, of course, temperature is a continuous variable. Halfway between 50 and 70 is 60 degrees. It's a continuous variable. But other variables are not. For example, species is not a continuous variable. There's nothing halfway between blue bunch wheatgrass and western yarrow. So those would be variables, or those would be units that you need to have bars for, not lines. Keep it simple. And remember that your figure should stand alone. If you drop it on the way to the parking lot and someone picks it up, they should be able to see what's going on. So it should stand alone. Now, just a few examples of how you might use your tables and charts while you're reporting data in the answer sheets for the assignments. One thing that might not be clear is that you do need to cite sources. Even in just answering the sheets that we have on the assignments, you do need to use references. In fact, that's how you would get a higher score on assignments, by making sure that you use references. Here was an example of a study, or of an answer from the past. Students said that the remnant prairie makes up less than 1% of the original Palouse. Well, that's true. It's a good sentence. But where did that student get that information from? It's not commonly known. So you don't have to cite things that are commonly known, but whenever you're using a specific number to support your point, you probably need to include a reference. So here would be another student who said a similar thing but used an appropriate reference. The Palouse Prairie is one of the most endangered ecosystems in the United States due to its high increase of noxious weeds, grazing, and agricultural uses. And then they cited NOS of 1995. And then they said it was just 1% of the historic prairie, again citing NOS et al. And then they include the reference in the end of their report. So if you really want to go above and beyond and get A's on assignments, you do need to combine or connect what you find in class with what is known in the literature or in the world, so you probably will need to use a reference. Another small point when you are developing your reports for this class, the assignment sheets, remember to be careful with how you use scientific names. Here's some ideas and tips. Every scientific name of a plant should be underlined or italicized. You don't necessarily need to use scientific names if it's clear, because remember the audience for these reports are people who are doing land management, usually people who are college educated but not specialists in the field. So you can decide whether you want to use scientific names or not. If it's something fairly common like smooth brome and most people would know what it is, you may not need to use it. But if you do use a scientific name, make sure to underline it or italicize it. Don't use the species codes. For those of you who have done some vegetation inventory, you know that the USDA plants database gives 4 to 6 letter codes for each plant in North America, and we do not use those codes in reporting data in a final report. We do use them when we're in the field, but not in text. So these would be examples of some species codes that would not be used in giving answers to the report. Of course, it would be worth some credit, but to really go above and beyond and get a high score on the assignment answers, don't use species codes. I want to leave you with a pretty good example of a student from a past class who made a very nice graph and used those data to make points in their answer sheet. So here was the graph. It's got both the X and Y axis, nice bars appropriately used. The bars over the means are the standard error bars showing the variation about those points. And then it's clear that the student truly understood what that chart was telling him or her, because this is what they wrote in their answer sheet. They said a higher density of smooth brome was found on the west aspect, while the northwest aspect contained very little. This was the opposite of blue bunch wheatgrass. The density of blue bunch wheatgrass was highest on the second site with the northwest aspect and lower on the west aspect. And in each case, they used their mean plus or minus the standard error to make their points. So when you're answering when you're putting your answers in the answer sheet, make sure to use your data to support your points, specifically the data that you found in your results, not in general, but very specifically. How did you make that conclusion based on your data? So I hope this helps as you move forward in this class.